start immediately. Thank you.
Discussing about resilient PNT system, NavIC, GNSS, and the challenge of spoofing and jamming. This session will examine how India and global stakeholders are strengthening resilient PNT architectures, including integration of NavIC with global GNSS systems, multi-constellation usage, alternative navigation solutions, and policy responses to interference threats. I would like to invite on stage our chair and moderator, Major General Subhasis Das, SMADG TACC, Directorate General of Signals. I would also like to invite the speakers, Lieutenant Colonel S. Velan, CEO, Elena Geosystems, Mr. Lokesh Kabdal, CEO, VymoIC, Mr. Akhileshwar Reddy, P. CTO, Sanyark Space, Professor Radhakant Padhi, IISC. I request all speakers to keep their remarks concise and within the allocated time. And now I hand over the proceedings to the moderator. Sir.
Thank you, MC. Good evening, ladies and gentlemen. Last session of the day, I stand before you and between you and the flights. So we'll keep it short. Just as a precursor, I've just got some opening thoughts. I'll give you 10 important statements on this very important topic. Everyone is aware of it. Just keep it at the back of your mind while this discussion is going on. First point, the first casualty of future warfare may not be communications, it may be navigation. Number 2, PNT systems have become so deeply integrated into military operations that they are often invisible until they fail. 3, GNSS is currently a paradox. GNSS is simultaneously one of the most greatest enablers and also one of the greatest vulnerabilities of modern military power. 4, the economics of attack and defense are heavily skewed in favor of the attacker. Next, a force that cannot accurately determine where it is located, where friendly forces are positioned, or where targets exist becomes operationally ineffective, even if all its platforms remain physically intact. Evolution from jamming to spoofing, currently as we see it, I deal with EW systems also. Jamming is an old threat, spoofing is the new threat, and SIMA is the emerging threat in this domain. We have to handle all three simultaneously. 7th point, nations that depend entirely on foreign navigation infrastructure risk strategic vulnerability during conflict. NavIC is therefore not just a technological achievement, it is a strategic necessity for us today. The future is a short PNT or APNT as many people call it. There are multiple layers and finally it has to be integrated and it has to be multi-sensor fusion in this domain also, specifically in the PNT domain. Point number 9, the future belongs not only to the most accurate navigation systems, but to the most resilient and trusted systems. And last, which I'm facing on a day-to-day basis, with increasing SDRization, manetization, and swarms of tactical networks, the relevance of resilient PMT increases multi-X factors. So with that, I'll not take too much time. We've got a very erudite and a very expert panel. On my right are sitting two doyens of the Indian industry in this sector. And on my left are two, you can say, the young guns who are blazing to go. So Colonel Velan, everyone knows about him. In fact, since the time we have heard about Indian PNT, we have heard about him and his company and how you can say he has actually navigated through multiple challenges. And today, where he has actually seen the entire story of this Indian NavIC and Indian PNT. So I'll not waste too much time. He is the founder of Elena, which he founded in 2012. He is also a recipient of the Igor Sikorsky Award. And over to you, sir. I'll request you to keep your speech to about 5 minutes so that we can give at least 10 minutes for questions.
Thank you. Good evening, everyone. Basically, when it comes to PNT, it's not a, the people mostly think that GNSS is a necessity for defense forces because GPS started that way. GPS was funded by American Air Force. Still now they hold the control over that GPS constellation, which is called NavStar constellation. GPS in local terms they're calling it. In colloquial terms in America they call it GPS. Now, that's a product of Cold War. And to oppose that, Russians put up GLONASS. That's why the context of GNSS has become something towards defense. Otherwise, GNSS is a tool for everyday activity within the country. If this is used properly, our losses will reduce. In all our industrial activity, the losses will reduce, efficiency will improve, overall doubling our output. Developed countries have used this technology to develop themselves. That's the importance of GNSS. Hence, resilient PNT becomes that much more important. That is, you should be able to use PNT on day-to-day basis, on a continual basis, without any disruption. Actually, of all technologies available for monitoring of your work, this technology is the cheapest one, continuous and high precision. These are the basic things. And I'll just tell my aspects about whatever I have understood about resilient PNT, working as jamming, spoofing, and all that. First thing, our system itself, our signal should be jamming resistant per se. Then our system should not permit spoofing. See, spoofing is practiced by whom? By the service provider himself. GPS L1 signals are spoofed actively in Middle East. By whom? By Americans themselves. So spoofing is a thing that is available in their architecture, so they can use that to spoof the signals. In case of NavIC, spoofing is not possible because it is not part of the architecture. Someone, third person, might try to spoof. Whereas internally, it doesn't have any mechanism to spoof the NavIC signals. We should go for a PNT, which is that type of PNT. First, which has got signals that are jamming hardened. In our case, let's say we went for NavIC. The signals are jamming hardened. And how it is that, see, for any receiver to receive, you should receive a signal of minus 153 dBm to minus 163 dBm, compared to GPS signal, which is minus 90 to minus 110. So our signals are so much more weaker. Anything, including a jamming signal which comes to our receivers, gets rejected as a white noise. As a noise, basically. It could be white noise or any type of thing. We reject anything about minus 130 dBm as a noise. We don't even deal with that. So any amount of jamming today, jammers which are designed for about minus 100 dBm, will not work with us. We have demonstrated this capability, and we are further working on this same capability to make it a full-fledged receiver, which is jamming resistant. Because your signal, GNSS signal in Indian context, is NavIC signal permits it. First point. Next is spoofing should not be permitted. As an architecture, should not be accepted by the world community. With any level of spoofing within any system which has got a spoofing parameter, the system should not be accepted. Then we'll have a resilient PNT. See, when it comes to space-based assets, space-based space-based operations, these space assets cover not only our country, If you see on the landmass side, we cover only 2% of the world map. Rest, our satellites cover much more distance than this. For example, NavIC satellites today cover from Gibraltar to New Zealand, they cover. It's not there. We are only telling for operational purposes, it is 1,500 kilometers. Some other things could be mentioned. Otherwise, they are covering from western end of Africa to eastern end of Australia into New Zealand also. So as such, this, the navigation or any space-based asset can be used by anyone else. And we stand to gain because our navigational system is the only thing for the equatorial region. This region has not been penetrated by people like GPS, Galileo, Baidu, or even the Japanese system which is being thought about, GLONASS. They are not in our region at all. Our region is open. That way we have put up a new system called NavIC. We are now improving the system with LEO PNT, with other additional MEO satellites also. We are improving the system. Such a system will actually help us to have a very resilient PNT. In PNT, in our context, we have more services than just positioning. Everyone assumes only positioning as a service, but timing is a major service for us. For a country like us, which is supposed to have 3 time zones, which spreads over 3 time zones, we have only 1 time. Very important for us. So timing is an essential service. We had introduced messaging as a service, which will help people in the border regions. Basically, in general purpose, or just if you take it, what is it about? It's for disaster management and for talking about certain weather conditions. Now, similar messaging service has to be brought in a bigger way, even to the extent of giving you arrival times of aircrafts, arrival times of trains. Messaging service should be utilized. So that's a huge opportunity that is there. Then coming on to picking up SOS signals through LEO satellites, or picking up a message from through LEO satellites from a handheld device. This entire, in navigation side, or I should say this way, navigation will integrate terrestrial and non-terrestrial networks. That's how it's going to be. At 6G level, it is already there in part of the 6G standards. They have said that it will also integrate NTN. Method to integrate is navigation. That's why navigation takes a very important precedence. And with this measure which I just talked about for jamming and spoofing and having multiple services spread onto multiple types of satellite platforms or the orbital planes, we'll be able to have a resilient PNT. Thank you, sir.
Thanks a lot, Colonel Velan. While the current situation as far as the NavIC is concerned is not very encouraging, however, what we understand from Colonel Velan as well as from the discussions which we are having, the future is bright, and let's look forward to a very integrated and a robust system. So next on my left is Lokesh. He is the founder and CEO of VymoIC, and they are into this new segment called LEO-based PNT, which is very exciting for all of us. And I'll request you to throw some light on this new technology. In fact, both the speakers on my left are dealing with this. So Lokesh, first, I'll request you to please open the house.
Thank you so much, sir. Thank you so much, SIA, for having me here. I'll give a brief history about VymoIC, how we started. That is very important to understand LEO PNT. So we have not just picked up a problem of LEO PNT and then try to solve it, because West is trying to solve it, right? So previously we were doing autonomous drone swarm. So we had a fleet of 60 drones. We were developing these drone swarms from scratch. We built our own RTK system, which is real-time kinematic positioning. And we were doing one show. So from this autonomous drone swarm, we were doing drone light show as an application. With our first show, which we did for AMC, which is Ahmedabad Municipal Corporation in Gujarat. So this show we were doing in the presence of Chief Minister of Gujarat. And so we were using RTK because if you see off the shelf, you don't get the precision which is required for autonomous drone swarming operations. We need centimeter level of positioning, but what is available is 3 to 5 meters from the existing constellations, depending on where exactly you are. So we implemented something called RTK, which is real-time kinematic positioning. Now in this, like you have a base station from which you send all these correction messages to all your drones. And the drones will receive the GPS signals. On the top of it, it will receive the correction messages, and then it will do the convergence, which will give a relative accuracy of centimeter level of precision. So this is what we implemented previously. And due to the CM security jammers, our RTK correction link got compromised. So you see, augmentation is something which is being utilized to give you precision accuracy, but at the same time, it is being vulnerable, right? So we are solving the problem of precision, but at the same time, we are creating one more link which can fail, right? So there are now two links which can fail and compromise the entire mission. First is the GPS signal itself. If someone tries to jam GPS signals, that is, have a certain frequency bands, let's say L1 band, L5 band, right? But the correction messages which you are sending to all these drones have a different frequency. Now, we were using 2.4 gigahertz and 433 megahertz at that particular instance, right? So if someone's tried to spoof or jam your correction link, then also your entire mission got compromised, right? So this is not a solution. So we thought, we brainstormed over it, like what is the next possible solution? We did a lot of research on quantum navigation, a lot of research on LEO PNT, and then picked up this problem, tried to solve it from the grass level roots. Now coming back to LEO PNT, right? So if you see all these spacefaring nations, be it USA, be it China, be it European Union, all these people are now trying to have multi-layer PNT architecture. So moving forward, resiliency does not mean a single layer architecture. It means a multi-layer PNT architecture. So we need to have a GEO PNT layer, we need to have a MEO PNT layer, we need to have a LEO PNT layer. Now LEO will come up with its own challenges as well as its own advantages. So I'll first speak about the major factor why the entire world is moving towards LEO PNT. So if you see, first of all, precision, right? We'll get the precision off the shelf from a LEO PNT satellite constellation, which we don't get from a MEO PNT, because the satellite moves very fast. So it inherently gives you better precision in terms of positioning, in terms of timing accuracy. Now, second is security. So let's say a MEO PNT satellite signal is coming from 20,000 kilometers up in space. Now, by the time it reaches Earth, your receiver, the signal strength is minus 130 dBm, which is even suppressed under the noise floor, right? The normal noise floor for a receiver is minus 100 dBm. Minus 130 dBm is the received power for your GPS signal. Now, it is very easy to jam and spoof these kind of signals because they don't have enough power. A normal SDR will able to jam and spoof the entire 5 to 6 kilometers with a very small power wattage. So this is how easy it is to jam and spoof the existing constellations. So LEO PNT will make it much more secure, where you can transmit power at a much higher signal strength. So 100 to 1,000 times much more powerful signals can be transmitted from the LEO PNT signal. And people will understand it's the property of being in LEO. So since you are closer, you'll be able to transmit more powerful signals. It's not that simple, right? Because see, if I am transmitting a signal which is 1,000 times more powerful, I will be jamming GPS signals, I will be jamming NavIC signal itself, which I will not be allowed to do. So there's a ITU, International Telecommunication Union, which will regulate the spectrum licensing. So when I'm transmitting 100 times to 1,000 times more powerful signals, I need to make sure that my signal will be interoperable with the existing constellation as well as compatible with the existing receiver infrastructure. So first, precision is there with the LEO PNT. Second, security is enhanced with the LEO PNT. Third, technological obsoleteness. Now, in this technological age where the technology is changing every 2 to 3 years, I need to make sure my satellites are upgraded with the advanced technologies. Let's say if I'm launching a MEO PNT or a GEO PNT satellite as of now, it will stuck there for the next 15 years. I will not be able to make any changes in the hardware or software. More or less something on the software, but not much in the hardware, right? But this is not something which I want. So I'll give you an example. Let's say quantum key distribution. This is something which, let's say we have two services coming from any GNSS constellation. One is SPS, which is standard positioning service. Another is RS, which is restricted services. Now RS has certain keys involved with it. Now, if I want to transmit these keys with a quantum key distribution, will I be able to do it with the existing constellation? No, because it's being stuck there for the next 15 years. This is one just example. If I want to improve any other technologies, hardware technologies up in the satellite system, I will not be able to do it. With LEO PNT, I'll be easily able to do it because every 5 years, I need to replenish the entire satellite constellation. The fourth is the cost itself. So if you see a LEO PNT satellite, the cost is very cheap because of you don't need to create multiple redundancies in a LEO PNT satellites. It's just up there for just 5 years. If you're building a satellite for 15 years, you need to create multiple redundancies. Let's say The current satellites, you take all the examples of GPS, Galileo, GLONASS, Beidou, or NavIC, they have around 4 atomic clocks because it is required to have 4 atomic clocks for the next 15 years. You cannot you need to create multiple redundancies basically for all this MEO or GEO PNT constellations, which is not required. So rather than including redundancy in my satellite, I will replace my entire one single satellite. That will be much cheaper for me to have redundancy in across 250 satellites. So the cost is very cheap. The launch cost is cheap. Let's take an example of a GEO PNT satellite. It takes, let's take NavIC example. It takes 400 CR to build a NavIC satellites, and it takes 400 CR to launch it, because you need an entire GSLV Mark II rocket to launch one single satellite. Right? So moving forward, these kind of expensive system is not sustainable. Fifth is availability. So now Japan has a QZSS constellation. Now why they built it is because of the problem which they faced because of urban canyons. So MEO PNT or GEO PNT is not very available at all locations. So let's say multipath issues is very prevalent in GEO and MEO PNT because the satellites moves very slow. If they have an obstruction in the field of view, it will keep obstructing it for a certain number of hours, let's say 2 hours or 3 hours, because the satellites moves very slowly. It cannot penetrate buildings, it cannot penetrate warehouses, so the availability of MEO and GEO PNT is very restricted. That's not the case with a LEO PNT satellite, both in terms of orbital velocity, which is very high for a LEO PNT satellite, so you'll get line of sight in maybe minutes if it is being obstructed in the first place. Second is it has much higher powerful signal, so it will be able to easily penetrate warehouses and buildings. So these are the 5 major advantages why we need LEO PNT as of now in today's world, rather than focusing more on the MEO or GEO PNT.
I think that was a masterclass. Thank you, Lokesh. Very nice. Very well done. Okay, we now move on to a speaker on the extreme left. He's Akhileshwar. He's the CTO of Sanyark Space. And when I was reading through their profile on the website, they have got a wonderful concept of a NavCom. That means on the same satellite, they are thinking of putting 2 payloads for both Nav and Com. I'll request you in case you can throw some light on this unique concept. So over to you. They're a new startup, 2025 startup, but once you hear them, you'll realize that they're really up in the scale. Over to you.
Yep. Thank you, sir. First of all, I want to thank SIA for arranging this. So the speakers before me, Lokesh and Velan ji, they've already spoken about the perspectives of NavIC and LEO PNT per se. So we are looking at it from a slightly different perspective from what they are looking towards that. So in terms of the navigation and communication integration per se, which Velan ji has briefly mentioned about 6G, wherein the non-terrestrial networks are becoming part of 6G standards from day one. So that is also our opinion in the sense that today, if you actually use any of your mobiles for navigating, you will observe that the moment you open your maps, within a few seconds, you get a position fix. That is because it's not just pure PNT that's working there. It's a PNT plus comms that is working there. So there's a concept called assisted GNSS, wherein your corrections that are supposed to come from the navigation satellite are being sent to you over the mobile network. So that is what is enabling it to give a position very fast. To test this, you can just switch off your data on your mobile phone and then go outside and open the maps. It will take at least a half a minute to a minute to actually get the position fix. So this concept of assisted GNSS has been there since release 16 or even earlier release 15 for NavIC. For GPS, it's been there almost like release 12 or release 13 of 3GPP, like it's at least 8 or 9 years ago. So if you see the evolution of this concept, as you go into 5G NR and 6G, wherein the release 19 and release 20 are going to come from 3GPP, the concept of integrating navigation and communication together into a single framework is what is evolving, in the sense that even from a satellite, when we are talking about non-terrestrial networks for communication, the concept of enabling non-GNSS based positioning through NTN is also evolving. So considering all these aspects, we have taken a decision to build a constellation that is working both on the navigation side and the communication side. Even if you look at the use cases per se, any logistic solution that is tracking supply chain, especially cold chain supply chain, cold storage supply chain, and many of the other shipping lanes, the position that is being computed has to go to a central server for monitoring. So we are bridging that gap of improving the position accuracy through our PNT signals, and then enabling a channel where that computed position along with other sensor information can get back to a central server through our comms signals. So that is the reason why we are getting into integrating this navigation and communication. So that's, anyway, as an answer to what Sir was asking about why we are going into navigation and communication. Coming to the main topic of resilient PNT per se, if you actually see one of the use cases of the wars that are happening even in Ukraine or US and Iran and all these things, you'll notice that there are two ways of approaching a jamming or spoofing situation, a situation. In the sense that there are jamming sources, there are spoofing sources, and they are affecting a radius around them in terms of what area they are jamming or what area they are spoofing, right? So one way is you increase the signal power, wherein VymoIC guys are working on that. You increase the signal power so that the radius shrinks a bit, in the sense that with the same amount of power, the area you can jam comes down because your signal strength is increasing. Ultimately, it's your ratio of signal strength to jamming strength that is affecting whether you're getting jammed or not. It's a similar case with spoofing, but it's slightly more involved. So one approach is, again, as I said, increase the signal strength. The other approach is, can you localize where the jamming or spoofing source is? So we are working on a kind of technology based on LEO-based GNSS receivers, which are looking at Earth. So based on that, we are trying to localize these sources in near real time, within a few minutes of the source being turned on, with an accuracy of few tens of meters. So that those become the priority targets to be taken out to prevent jamming and spoofing. So we are taking the other approach of how to prevent jamming and spoofing. So basically that's in a view of overview of what we are doing as a LEO PNT constellation to actually build resilience into the system. In addition to that, we are also working on something called PPP RTK, which is basically a way of improving the accuracy of traditional GNSS systems, they're like NavIC, GPS, etc., and bring it from a typical of 2 to 5 meters to sub-centimeter level. So that's an overview of what we are doing as a company. Thank you, sir.
Okay. So before I come to Dr. Padhi, just two small questions for, since it is related. Firstly, for Lokesh, in case you can just throw some light on this, if this PNT segment comes down at the LEO level, will it increase the vulnerability of the system? Or what is your opinion on the vulnerability of the space segment, number one? To you, Akhileshwar, do you see any relevance of the restricted service in case of the LEO-based PNT systems? In your opinion, are you working on it? Okay, over to you, Lokesh.
Right. So as far as vulnerability of space segment is concerned, I think that's been the case as of now. So recently, if you see the Ukraine-Russia war, so there have been some news where the space-based jamming has reached to the orbit 1,200 miles from the Earth's surface, which covers the entire LEO orbit, as in LEO is less than 2,000 kilometers. So it reaches beyond that. So now all the satellites which we are using is susceptible for jamming, spoofing, all these kind of different activities in the space segment itself. So let me give you an example. So let's say an Earth observation satellite, right? All these satellites will have a clock inside it for their functioning. Now, these clocks are not very stable, so they will use GPS disciplining. Now, let's say if GPS itself is jammed in a LEO orbit, then you will not be able to do the functionality of Earth observation satellite because the clock will not allow you to. Coming to your ELINT satellites, which is even more crucial because you need very high time synchronization for ELINT satellites. Now, if GPS or any other things will jammed and spoofed, this is, I'm very talking specific to PNT requirements. There are other concerns which is there in terms of space segment jamming and spoofing and vulnerabilities, right? So we know all about RPO systems now being used for attacking different satellites. I'll not get into those things. I'll restrict myself for PNT side of things. So all this, again, coming back to ELINT satellites, let's say, they also use GPS disciplined oscillators. Now, what if GPS is intentionally degraded or it has been spoofed in space itself, right? So that's another issue which we are trying to solve at VymoIC, where we for our PNT requirements are building atomic clocks which will provide very good frequency stability even if there is no disciplining, and the disciplining can be done from ground itself. Then another part of space segment which is being utilized for jamming and spoofing. Now, we are getting PNT from space. Now assume why it is mandatory to give only PNT signals from space. Why not offensive PNT? If I'm able to transmit VymoIC signal, why not be able to do a GPS signal from my satellites? I will be easily able to do it. Are you sure whether you are receiving Beidou signal or you're using GPS signal? So let's say there's a defense vehicle which is being operational. Are we sure that the signal which we are receiving is GPS signal or it's a GPS mimicked signal transmitted by Beidou? So all these are now becoming a concern which we are trying to solve at VymoIC. So, yes, sir.
Thank you. Wonderfully spoken. Akhileshwar, if you could just spend 2 minutes.
Yeah. So your question was about RS service, relevance of it, and what we are doing related to that, right? So coincidentally, I worked on the NavIC RS service when I was at ISRO. So the main difference between the RS service and the SPS service is not in its accuracy. It's more from the perspective of how the signal is designed and how it's robust against spoofing. So the concept comes from the way the PRN codes are defined, in the sense that the codes that are there in RS are long codes, they're again encrypted, and there's a secure encryption key distribution mechanism and so on and so forth. So that essentially prevents a spoofing per se. So in our case, even when we are thinking of our own PNT service, we are keeping in mind the necessity of putting a RS similar signal. But we are more working on that in a particular specific band, not all bands, because obviously we can't afford to have such a complex signal in all the commercial receivers. So we are working on that. And in addition to your question about the relevance of it for here, it is relevant because half the application cases for LEO-based PNT are in defense, and those are the ones that are more critical for the nation. So we are very much working on that.
Thank you. Thanks a lot. Our last speaker of the panel, Dr. Radhakant Padhi. He is a professor of aerospace engineering and cyber physical systems in IISc Bangalore. He was also part of the core team of the Indian space program. And Sir has also been completely part of the Chandrayaan series. And he is actually a user of this entire technology, more of a user. So I request Professor Padhi to please cover those aspects.
Audible? Okay, fantastic. Thank you for that. I just first a small correction, Major General Das. It was not the last session of the day, it was actually last session of the event. After this event, the session is completely over, we are going to go back. And then it is, I'm also the last speaker of the entire show, basically, right? After that, you know, speaker. So that way. Okay, so let's start with something. So I'm telling this, see, all of you probably using this, whatever the PNT solutions, must be doing this, some sort of signal processing. In the signal processing, we call as outlier. No, outlier signal needs to be rejected. They don't have to be taken seriously, basically. So in that sense, you can consider me as a kind of outlier, basically. So I'm not working in this field, but we start from where they give. Now, how many people are young? I see a lot of young people here. So how many people want to do your master PhD? Just for masters and PhD. Only 1, 2, 3, 4, whatever actually. Good, fantastic. So this is actually a fantastic domain to work with. And then I'll list out a few things, what you can think about and all that way. And before going there, okay, the very first thing that we talk about is users. What does that mean? I don't use the communication part of it so much. I actually use the navigation part, because what we call as autonomous vehicles, no, autonomous drones, autonomous missiles, autonomous Chandrayaan, whatever, they're all autonomous missions, they heavily rely on navigation. To some extent timing also, but the primary position requirement and the position and velocity, that's both the translational rotation, right? So those things come from variety of sensors, not the satellites only. Now going back to the students again, I mean, how many of you have copied in the exam? It's a very, very bad question, by the way. Anybody has copied in the exam? No, I don't know, I'll forget it anyway. Oh, yeah, fantastic. Thanks for being honest. Now the question is, suppose you want to copy, and you know that that fellow is not going to give you the right answer. What do you have to do? The question is like this, right? Suppose you want to copy in the exam, but you know that that person that is going to give you copy is going to mislead you. Then what are you going to do? Don't copy that fellow, that's it actually. That's how it is actually. That is the whole idea of rejecting these PNT solutions whenever that is not reliable. So whenever you know for sure they are getting jammed and spoofed and all that, don't use it. Now the question is, if you don't use it, what are your options that you are having basically, right? You should have some other options to do all that basically that way. So what are the reasons for that, and they've talked in elaborate why that happens, all sort of thing. There are 2-3 kind of primary things that you can think about. One is the signal vulnerabilities, right? So essentially they talked in length. So signal can be so much kind of spoofing, jamming, all sort of thing, masking. You know, there will be some ionospheric disturbance that can be randomly, you cannot predict it, all sort of things are there. And then there is electromagnetic interference. There is something intentional GNSS denial, like if you are all talking about other things and all that. So those are the reasons that we are talking about. But what are the GPS denied environments? Yeah, there are many, many environments. Both indoor problem can be there. Right now, how many people get, GPS signal is not available. Indoor will not be available, under the bridge not available, mining is not available, defense it is certainly jammed and all this not available. There are many, many places that is not available. But if it is not available, do you feel requirements? GPS is not available, but missions should go on. So should go on, right? Missions should go on. So what are the missions that you talk about? You can missions talk about, this, there are a lot of missions you can think about. So autonomous inspection you talk about, mining inspection you can talk about, military inspection you talk about, the defense applications you talk about. That should go on, right? So whatever it is. So there are so many things that you're talking about operational scenarios where despite not having this, we are supposed to carry on basically. So what are the solutions that you are talking about? So there are something that we teach in very standard things, dead reckoning. Now this INS systems, inertial navigation system, where you have accelerometer, gyroscope with varieties of various high degree of accuracy. If you have got fantastic levels of accuracy, they are very well kind of calibrated and they are very, very well kind of aligned and all sort of things, then you can actually rely on them. And that is what happens in missiles, launch vehicles and all that, to some extent basically. Then this concept of visual odometry. Now how many of you heard about it? Visual odometry, right? So we can talk about partly sometimes it's available, I do it and then close my eyes and go something, right? That way. So whenever eyes are open, I can see it, get a little bit of GPS and then I close my eyes and then go for a little more time. Then you talk about geotagging basically, GIS information in the loop. So there are many things that are there available and these are fantastic places to do research by the way. There are many, many things that are not known. There can be very good computational thing, very good hardware, software you can also talk about. LiDAR, we can talk about LiDARs also, like kind of in short range radars and all that can talk about, and also talk about terrain relative navigation, right? All sort of things are possible there. So of course, what are you talking about that classifications now? You can talk about what are the order of accuracy, there are plus points, minus points, where you do, what you do on that actually. So in all these things, if you really want to do research on, there is something fantastic technique we call about signal processing. And the very signal processing is a hardcore core thing. So even if you do a kind of electronic system development, you have to do signal processing anyway. Now, one of the things that talks about is Kalman filter, right? How many of you heard about Kalman filter? Everybody almost, right? How many of you know the details of Kalman filter inside? How it works, why it works, what is random noise, what is white noise, what non-colored noise, why color, why white, all sort of things, right? So that actually opens up a Pandora box for research actually. In fact, it turns out that in Kalman filter, what is so-called white noise is what? No, what is white noise? In a nutshell, 2 seconds if you give me. I mean, white noise is nothing but a perfect mad fellow actually. I call that in my class. The perfectly mad fellow will not have any correlation between what he talked just now and what he is going to talk 1 second later. So the autocorrelation is delta function actually. Autocorrelation is delta function. What you tell now is now. The moment you talk a little bit later is completely uncorrelated. So that kind of noise is called white noise actually. So that can, see we are teaching material and all, I will leave it there. But none of the reality noise is like that. And then this white noise is a backbone of Kalman filter. So it's not going to work in a practical scenario. And that too in a Gaussian noise. Now Gaussian noise is also not realistic. Now you have got this tail problem also basically, right? So you don't even know what's the distribution. Distribution, you assume that is going to cause some noise, right? You don't even know basically. So can you really construct that distribution from the data? So that data if you really talk about, then you talk about particle filter, right? You go to particle filter. So Kalman filter kind of conveniently talks about additive noise. No, it's not additive noise. It can be multiplicative also. So there are many issues that you can think about, and then various permutation, combination, all that you can think, all sorts of things. Similarly, when you go to visual odometry, again you talk about some vision information, can you do real time, right? Can you really quickly can infer something that is coming out? Can you really talk about low quality image, high quality navigation? So there are many problems that you can think about for talking about a very good quality PhD research and then finally leading to products basically. So why I'm standing here, of course I am a professor, but we also have a small startup company, and that company talks about very high precision navigation, high precision guidance and control, also robust guidance and control. So where we need high precision navigation. So that is what you start with actually, that way. So this is where this loop is getting closed there. So more on that you can talk after this session probably. Those of you are interested, I'm also having a course. The course is for about a week's course in getting in IISC, July 6 to 11. We'll talk about navigation and surveillance. So we talk about INS, GPS, integration filter, all sort of things there is from me. And then there are experts who will talk about surveillance actually. Surveillance is basically radar systems, and then SAR system, radar system, or electro-optic system, various AI systems, all these things is getting covered. Those of you are welcome, those of you are interested, spend a week and then come to IISC, enjoy your thing, and you'll have a tons of knowledge there. Thank you very much.
Thank you, Dr. Padhi. Okay, we have time for 5 minutes of questions. I'll request anyone to just pick up a mic and throw your questions. In case I've got 1 minute, sir, I'll throw a small question to Colonel Velan. It's been rankling my mind. Since he's an actual practitioner, I'll request him to just throw some light on this multi-sensors used in INS fusion. In case you can just give a mind on this aspect. Everyone has been speaking about it. How is the practical implementation?
Yeah, this, when you talk about resilient PNT, we should not talk about just only space. I think mic is on. You can hear me now clearly?
Yes, yes.
This, when we talk about resilient PNT, we should not talk only about space-based resilience. We should also talk about other issues, what Dr. Padhi had brought out about the INS part of it also is a resilience aspect into it. Today, the developments are so high, like for our tanks, someone said that we'll improve the tanks with NavIC and all that. So one perception, someone made a market study and brought out a cost of 183 crores or so of an implementation. You won't believe it, when this was put to the market, someone came out with a 10 crore solution, 1/18th of the cost. He is able to still make up whatever, he must be making his profit and all that, but he is able to, he says he can give a solution at 1/18th of the cost, which we thought 185 itself is lesser. That's one aspect of it. That's a huge potential this multi-sensor fusion has got. Another thing is that in one of the RPVs that we are using actively today for anti-militancy type of activity, I found one sensor was there, one sensor that FOC-based gyro was there, that was about 20 kgs weight was there. When I went with my product, the entire product, navigation, everything put together is only 1 kilo. Whereas for him, it is more than 20 kilos. So with the 20 kilos, I can have some other payload and have a better camera, maybe better electronics to fuse video which they are taking it and all that, and the entire efficacy can be changed. This is a fusion, this is the ability of multi-sensor fusion, either on the platform or on the receiving side.
Thank you so much. Any questions? Yes.
There are two short questions. One is that who are the clients of NavIC today? Who have been the clients of NavIC? And what is the plan for the future? From the commercial point of view, the viability of having clients. And the second thing is, Lokesh, can kindly tell me that if you're going to invest in LEO, why don't you invest in multifunctional satellites rather than, somebody's doing ISR and somebody is doing PNT and somebody is doing communication broadband. So if you're going to do all this, you might as well make a multifunctional satellite. Why do you keep picking on one thing? Thank you.
So first question, first part, let me answer. Maybe other part, Akhileshwar will be able to answer better. Clients of NavIC today is Armed Forces, Army, Navy, Air Force. One of our product, NavIC-based product, is in every infantry battalion today. One is there in every artillery regiment. One is going into every armored regiment. And then it is getting inducted into signals. It is getting inducted into, today it is already there, inducted already.
Has this been used?
Yes, yes.
In the past?
Yes, it is being used. We have inducted 3 years back. Then today you are asking about lot of smuggling boats, or they are smuggling in the Arabian Sea being caught and all that. There are some petrol boats that are being used. They are using NavIC for last 3 years.
With 3 satellites?
No, today is 3 satellites. Earlier it was not 3 satellites.
Now, see the
Now
point,
3 satellites.
At some point,
Yeah.
it has come down to 3 satellites. So
I'll-
what do you do with your clients?
No, I'll tell you, sir, this thing. So 3 satellite is a misconception, is being boosted or being pushed by GPS lobby in the country. There are 11 satellites today, NavIC satellites. When I say NavIC, navigation with Indian constellation, consists of IRNSS satellites and Gagan satellites put together. We can still use these satellites with L5 based navigation. That's they are talking about 3 satellites. There is 3 satellites are giving S band and L5 band. That's correct. Only L5 positional service is not there. But with L1, L5, I'm able to give you 1 meter accuracy, which no other system in the world is able to give you.
You think people in this room are using NavIC or can use NavIc? Or
They can use. So my product has been inducted.
This is one thing that you can do if
Yeah.
that is so.
Yes. Okay.
Just to add on to that, I'll just talk about the commercial part of it. By design, NavIC was designed as an interoperable system in the sense that if you have more than 2 satellites, that can be used with any other constellation per se as an interoperable system. And most of the Qualcomm chipsets that have been released in the last 2-3 years and most of the mobile phones by default use NavIC. Just a small point.
No,
to add.
excellent. Thank you.
Standalone, sir, we cannot use NavIC as of now. As in his part is, since it is interoperable.
No, actually my question was standalone, but
Yeah, we
Gagan
cannot
and all is understood. You have, today you have the ability of picking up any constellation, aggregating any PNT devices put together and get a very good positioning. But when you are looking at something which is purely indigenous, which neither can be spoofed nor can be denied, that is where the question of purity comes in.
So that's what we demonstrated a month back. That's what during my talk also I told you, we have demonstrated something which is, we work through jamming. Is it possible, or you not have heard about it? We have demonstrated can work through NavIC, can work through jamming using NavIC. We can discuss the things, sir. But essentially, what you say is that we need to strengthen NavIC. Yes, that is well taken, sir. We need to put up satellites faster with the new set of satellites.
Yeah, that's exactly the point, sir. So that's in my opening remarks also I mentioned this. Okay, Lokesh, if you can cover the second part.
Sure, sir. So I think
And
that's a
one
very,
last
very
question.
valid question. As far as LEO PNT is concerned, people have been questioning the economic feasibility of it from the very first day. I think for us also, like we right now focusing primarily on the PNT payload. We will prove the PNT capability for a few of our satellites, and then we also have plans to integrate other payloads as well moving forward. There's a slight difficulty, as in if you see, various payload will have various constellation demands. So let's say Earth observation had slightly different requirements in terms of constellation, in terms of payload. PNT has a separate requirement in terms of constellation architecture, in terms of demands. But like we are working towards it, we also have a discussion within space as well of multi-payload satellite, because we are the ones who will be having 250 satellites. So right now our constellation has 244 satellites. So why not to use it for some other applications as well? We definitely have this in our mind. Thank you so much, sir.
Sir, I have a question regarding the positioning. When we are talking of positioning, these are using satellites for ground-based positioning, right? I mean, vehicles on the ground or whatever. As far as I know, I'm a retired Group Captain Bhattacharya. I was for a long time with Satellite Control Center in Bhopal, controlling ISRO's satellite, ISR satellites for us. So the accuracy, the orbit determination of these satellites themselves use SPS data, right? SPS data is offloaded and then run onto their what you call FDAM systems to generate future predicted paths, which is again used for payload determination and etc. For other tasks that they are doing. So for Colonel Velan or maybe for Lokesh, are we planning to have NavIC as to substitute this? Will it be possible? Because these are also LEO satellites and the future ISR satellites that, as I know, they are also going to be LEO. The VymoIC PNT will also be in LEO, right? So if we consider a pure no GPS solution.
I think I might be the better person to answer that because there is already a receiver that is developed at URSC ISRO which uses NavIC signals for doing positioning in LEO.
Okay. So adding to that, sir, I think we are also in our PNT satellite also need orbit determination. So for us, it's even more precise. So we use word POD, precise orbit determination. We are also having this algorithm in our satellites. So we are doing real-time onboard processing of this precise orbit determination. So we will not be uplinking the OD requirements from the ground stations. But definitely we are working on something which will take measurements from the NavIC satellites and then physics models will be incorporated in the model itself and then we'll get the better OD positions. So we are working on it to integrate NavIC on these kind of missions.
Okay. Ladies and gentlemen, thank you for the patient hearing. It's been a wonderful session. And thank you, panelists. Thanks a lot.
Thank you for a highly insightful session. I request dignitaries to join us for a photograph. Please give a huge round of applause for our distinguished panel.